So friends, today I'm going to discuss the basic concept of differential coefficient of a function with respect to a variable, that is the meaning of dy upon dx. So you must be familiar with this very much if you're a math student, especially in 12th standard or undergraduate courses like BSc or BTech. But very rarely people used to think what is the basic meaning of dy upon dx. So today I'm going to discuss this. As we know that y is assumed as a function of x, then x is called independent variable and y is called dependent variable. And this is because the value of x doesn't depend on the value of y, while the value of y depends solely on the value of x. So we are going to give a little change in the value of x. So consequently, the value of y will also be changed. So suppose if x is given a change delta x and the corresponding change in y the corresponding change in y is delta y. So we may write it as y plus delta y is equal to f x plus delta x. That is, if we give an increment or decrement, that means a change of delta x in the value of x, consequently the value of y is changed by delta y and it becomes y plus delta y. So let it be equation number 1 and this equation number 2. Now if we transpose y to right hand side, we have delta y is equal to f x plus delta x minus y. And since from equation number 1 y is equal to fx, so if we substitute y is equal to fx in this equation, we have delta y is equal to fx plus delta x minus fx. Now if we want to find out the ratio in the change in the value of the ratio of change in y with respect to the change in x, so we need to divide this equation by delta x. So simply dividing both sides by delta x, we get delta y upon delta x is equal to f x plus delta x minus fx upon delta x. Now, since delta x is a very small quantity, to show this mathematically, we used to write limit delta x tends to 0 del y upon delta x is equal to limit delta x tends to 0 fx plus delta x minus fx upon delta x. In maths, we denote this expression. In mathematics, we denote this expression as dy upon dx. In differential calculus, we denote limit delta x tends to 0 delta y upon delta x by dy upon dx. So we may write this equation as dy upon dx is equal to limit delta x tends to 0 f x plus delta x minus fx upon delta x. Or in simple language, we can say that the ratio of change in the value of y with respect to change in the value of x, when the change in x is very small, that is called differential coefficient of y with respect to x, and which is denoted by dy upon dx.